Okay, my name is Trevor Bloom and I'm a freshman here at the University of Mount Union.
My name is Whitney Riddle and I'm also a freshman here at the University of Mount Union.
So we are all college students here, obviously, and we hate spending money on things that are basic like toothpaste. So today, Whitney and I are going to be making toothpaste not only for ourselves but for our entire hall.
So what we're going to need here is we're going to need 30 milliliters of hydrogen peroxide, which we already have here in our graduated cylinders. We're also going to need dish soap and then 2 different amounts of potassium iodide, and we have 3 grams and 6 grams. So make sure you guys wear gloves, goggles, and a lab apron for this because potassium iodide is an irritant and hydrogen peroxide is very corrosive. So what we're going to do first is we're going to add some dish soap to our hydrogen peroxide base.
And then we are going to add some food coloring, whatever preference you want your toothpaste to be.
I'm going to do red and blue, which should make purple, because go Durs.
And I'm going to use just a little bit of red to give off a pink hue. Just watch whenever we add our specific amounts of potassium iodide, just make sure you watch the difference in our reactions.
Yeah, I'm going to use 3 grams.
And I'm going to use 6 grams.
And as you can see, before we add it, there's no reaction happening. It's just sitting in there without anything.
Okay, so as you can see, the dish soap traps the oxygen bubbles. So then the hydrogen peroxide oxidizes with the iodine and releases oxygen gas. So then the gas gets trapped in the soap, creating the foam, and then the foam squirts out of the top of the graduated cylinder, which resembles that of whenever you squeeze toothpaste out of its tube. So then after the reaction, it's safe to dispose of down the drain.
This reaction here demonstrates the scientific principle of a catalyst. And for those of you guys who don't know, a catalyst is any chemical which affects the rate of a reaction without actually changing the chemical composition of the catalyst itself. So the catalyst here is going to determine whether the reaction is going to go faster or slower than it normally should. According to Peterson, when a catalyst enhances the rate of a reaction, it is known as a promoter.
In our experiment, the potassium iodide is our promoter, and we can see this in my experiment where mine reacted faster than Whitney's did because I added the 6 grams of potassium iodide where she added the 3. So her potassium iodide is more proportionate to the 30 milliliters of hydrogen peroxide.
Now, although catalysts are very important, the key ingredient is really the hydrogen peroxide. According to Peterson, hydrogen peroxide is a molecule that is made up of both hydrogen and oxygen atoms, and when they dissociate, it causes a very rapid release of oxygen, as you could see with the bubbles. According to the National Science and Technology Center, our hydrogen peroxide is going to undergo a chemical reaction to break down into water and oxygen. And we can write out this formula as a decomposition reaction up here. What we have is 2 reactions occurring at the same time. We have hydrogen peroxide reacting with iodine to form liquid water and iodine monoxide. And we also have the iodine monoxide reacting with hydrogen peroxide to form liquid water, oxygen gas, and iodine. And to make a net reaction that's going to occur, what we can do is we can add up all of the reactions on both sides that occur. And since the iodine is over here and also over here, those are going to cancel each other out. And since the iodine monoxide is here and here, those are also going to cancel each other out. So what we're left with is 2 hydrogen peroxides in the aqueous state to decompose to form 2 waters in the liquid state, and then oxygen gas. So this here is really our net reaction that's happening and occurring when we do our experiment.
So then if the soap is added before we add our catalyst, then this is going to create the toothpaste-like substance that you see because the soap is mixing with the oxygen, and then that's whenever the reaction occurs. And then Science Clarified states that the scientific principle of a catalyst can be demonstrated through brewing beer, making soap, fermenting wine to create vinegar, and also leavening bread. Science Clarified also states that biochemists demonstrated that the catalysts bring about fermentation of alcohol from the living yeast cells are a chemical substance. One example of an enzyme would be a cytochrome, and a cytochrome aids the respiratory system by catalyzing the oxygen and hydrogen cells within each cell.
So while doing research on catalysts, I found some really interesting facts regarding them. On Science Clarified, I found out that the reactions of hydrogen that form helium on the surface of the sun is catalyzed by carbon, which is the element that's found in all of the living things on Earth. And there's also, back in the 1970s, automobile exhaust really started to become a problem. So that's when the federal government decided to mandate the use of catalytic converters. And for those of you who don't know, a catalytic converter is a device that employs the use of a catalyst to transform the pollutants from the exhaust into less harmful substances when it's put out into the air.
So after visualizing our experiment and listening to all of the ways that catalysts are used, hopefully when you guys are brought about to them in the real world, you will be able to pick them out.
Thank you.
Thank you.